Now we get to the fun stuff. In what I'm demonstrating, again, does not have the data leaves in there. So think of this as data is being read in, it's helping construct the overall pointer directional set of the tree, and then the data is being dropped in its respective L location. So we have to remember that as we're doing all this. Now, it's all based off of your original value of M. And what is M again? M is the number of kids that we can have. 3 for this one, so we can have a maximum of 3 kids, and an M of 7. We're going to have a lot of kids with that. We have to keep that in the back of our mind because with all this data that's being dropped in, our original node is going to eventually get overloaded with data. We're going to have to do something with it, and it's called promotion. So let's look at the promotion. So in this example, because 5 is visually easier, if we look at this current one, you see all the spikes come out here. That's actually 6. Remember, M is a number of pointers coming out. Right now it's currently at 6. That's a problem. So we got to break it up so it's less. So what are we going to do? It's actually very easy. All we're going to do is we're going to pick the middle number, promote it, and then break the other 2 nodes into equal halves. So then we have our M's showing up now are most definitely less than our 5. Now what happens if we have an even number? So again, you're going to see all the pointers kind of sticking out of there, and there's going to be 5, which is too much. So we have to do a promotion. Now using the equation that we have here, and by the way, this is not consistent with everything that you see on the web, so be very careful about it. A lot of them agree with what I do, books agree with it. There's some other ones that do it slightly different. But that's going to be, if we have an even number, we're going to do the floor of m minus 1 divided by 2. So in reality, this is going to be index 1, because it'll be, what, 1.5, something like that. But anyway, so that'll be our index 1. So that one right there got promoted. And we broke them up into 2 different nodes. And again, the m's are coming out here that are now less than 4. So you'll notice a couple of natural things that happen with this. Number 1, promotion. Promotion only pushes up 1 item towards the top. Number 2, it's still an ordered tree. I'm going to go back to 5 here. You should be able to find 2 pretty quickly because, again, it's an ordered tree. Number 3 is that your tree is always going to have a balanced lower bottom to it because, again, naturally splitting it up by 2 to go ahead and break that up. And you're going to constantly be breaking up into 2 pieces to keep that balance throughout the entire tree. Now, for giggles, if we were having to put a new number in here, let's say 0 for this one. So we start from the top, just like a binary tree, but it's not. 0 is less than, what is that, 2? Then down to 1, and then we would add 1 more node right here in this location. So notice we would continue doing the overall same kind of search in place as we're adding data to our tree. So let's start off with this example from scratch. Again, our most important feature other than the data is what our M is going to be. So personally, I think of it as M being 5. I know if a node hits the 5th piece of data, we got problems. We got to do a promotion. So think of it that way. So that's why when you see this at first, you see the first 4 being put in here because we know there's no promotions, but notice they are put in an order of 1, 2, 8, and 12. That's got to happen because remember, when we're doing our searching, we know things that are less than will go to the left, things that are greater than will go to the right. And again, there's actually spikes that are coming out of here, but I'm putting that away for now. So as soon as I add my next number, which is 25, temporarily, even though I know, oh, it's going to be the 5th node, I know I'm going to have to do a promotion, temporarily, I go ahead and put the 25 into place only because I need to know what the middle is going to be. So again, that 25 is placed in order with the rest of the nodes. Because of that, I know with the M of 5, and we've done this before, it's going to be that middle node that's going to get promoted, and well, there it is, exactly like I said. It will be promoted from there. So our next number that we add is going to be 5. So as we're adding, we're going to the nodes. 5 is less than 8. Okay, drop down, we do have a possibility. Okay, great. This only had 2. It's really this one we should be looking at. So I'm going to add 5 to it. Again, that's not greater than 5 for the m, so we're okay. We need to move on from there. So 2 more numbers that I added were 14 and 28. And notice, well, they went in pretty easily. Now, I stopped here for a reason. And the reason is because we're at 4 here. We know that, if we add 1 more to this side, we're going to end up having to break it up again. So what's going to happen here? Well, we add 17. 17, I'm going to start from up here. 17 is greater than 8, and well, we're going to add 17 in between the 14 and the 25 there. So we know, we've got a problem. Now, again, we do the exact same thing. You put 17 in order, and then we're going to go ahead and break it up and promote the 17. Now, notice how this works out here, and of course it crosses right in the wrong spot, is that 17 gets promoted to that node that was just above it. It doesn't get by itself, because remember, this node only had 1 in there. It's definitely less than 5, so we have room to add things in here. So notice how it still makes a nice flat layout. We went ahead and promoted 17 up to the upper node because we had space for it. So neat how we can do that promotion, and it really doesn't affect too much of the tree. But again, notice how fast it is on if we have to search for something. It points us in the right direction pretty much automatically. So now I went ahead and added 7, 52, 16, and 48. And notice it really didn't do anything to it here. But notice that we do have to worry about this section over here because we're about to hit 5. And I'll be darned if we don't. We're going to add 68 to that. So 68 really would have been placed where? 52. 68 actually would have been placed right here. So what are we going to promote? We're going to promote that 48. Now again, we can promote it without an issue because this node is still less than 5. Now what happens, just for giggles, what happens if this node gets too big? You do the same thing. Break it up, push up the middle. Okay. Notice how, again, it's really kind of like a bottom-up type of structure where we feed everything to the bottom, and then if there's any promotions, it percolates from there. So we added the 68. 68, sorry, not the 68 was added here, but we promoted the 48 right here. So we're going to add 3, and 3 got sent all the way to the left-hand side. And then we're going to add our 29, 26, 53, 93, 55. Wow, I can't even read here. But anyway, there's no real big changes with that. So that's the good news. And then the last one was added 45. And darn if I just didn't mention that. So notice that when I added 45, and again, I'm going to go to the previous one. 45 is in between 17 and 48 here. So I'm going to drop down, and 45 would be placed right here. Okay? We know that that node would be too large, so now we're going to have to promote that 28 up. But here's the problem. That node already has 4 as well. So let's temporarily put 28 in the middle there. And then we know we have our 3, 8, 17, 28, and 48. Which one are we going to promote? That's the 17 that you see right here. And notice it did the exact same thing of breaking that up from there. So again, we got to percolate up. Every time we do a promotion, we got to double check. Okay, is that M too large? Yes, it is. Got to break it up again. Is that M too large? Notice how that's worked out. But again, the tree is flat the entire time as we're doing all of our insertions and promotions.